All right, so today's review is just going to be solving exponential equations using logs. So the first thing is to remember, in our last video we talked about a little bit how logs and exponents are inverses of each other. So that's important for this topic. Okay, so since they're inverses, if I were to draw, let's do like 10 to the x and then log of x. So this graph is the exponential. This would look like that, and it's going to cross at y is equal to 1, x is equal to 0 there. And then the log graph sort of looks exactly the same, but flipped. So this one crosses at x is equal to 1. And so since these graphs are inverses of each other, that just means that they're flipped over the line y is equal to x. So you can see that if you put the two graphs on the same axis, you can see that they're just like mirror images of each other over the line y is equal to x. So that's the definition of inverse functions, and we see that logs and exponents are inverse functions. Okay, so now we're going to do a very basic example of solving an exponential equation. So if we take just the equation 10 to the x is equal to 100, so something very simple. Now obviously we can kind of just eyeball this and solve it, or another way to solve it would be to say, well, I can write this in logarithmic form. And if we wanted to write this equation in logarithmic form, we would write it like this. And then we could just plug this into our calculator and we would get x is equal to 2. But I'm going to solve it in a slightly more complicated way first. So let's say instead of just immediately going to the logarithmic form, I say, okay, I'm going to take the log of both sides of this equation. So I'm going to take log base 10 of 10 to the x, and I'm going to take log base 10 of 100. So I did the same thing to both sides of my equation, and now I can rewrite things a little bit. So I know that log of 10 to the x I can rewrite as x log 10, base 10. And so then this is equal to log of 100. But log base 10 of 10 is just equal to 1. That was one of our log rules that we saw in the previous video, was that when the base and the argument of your log are the same, that's just equal to 1. So this is just equal to 1. So then I just have x is equal to log of 100, base 10. And so this is obviously equal to 2. And we're back at the same place we kind of did in one step earlier. So now this might seem like a really roundabout way to solve a pretty simple equation, and it is, but obviously we're going to be doing, most equations are not going to be this simple, and you're going to need to take the log of both sides and solve for x that way. Okay, so let's see a similar simple example, but in a different base. So let's do 3 to the x is equal to 27. So now we have a different base. So the first way to do this is just take the log base 3 of both sides. So I'm just going to take log base 3 of both sides. And I can rewrite this side as x log 3 base 3, and then I have log of 27 base 3 over here. And now the same thing happens where log base 3 of 3 is just equal to 1, so that cancels out. And then I'm just left with x is equal to log base 3 of 27, which you can just plug into your calculator and you find is equal to 3. Okay, so this one again you can figure out by eyeballing, but the important thing here is the different base. So when I have my exponent has a base of 3, I took a log with that same base so that it would basically cancel out and I would get that 1 there. That's one way to solve this equation. Now you could say, okay, well, what if I don't want to think about changing my bases every time I do a different equation? I just want to always do log base 10. So that's fine. So let's do it that way. So let's do the exact same equation without worrying about a log with a different base. So let's just take log base 10 of both sides. So we're going to end up with this. And now we have to solve for x. So now this does not just simplify down to 1, so I'm going to have to divide both sides by log of 3 base 10. So I'm going to have x is equal to log base 10 of 27 over log base 10 of 3. So now this is actually the exact same thing we had in the previous slide. This is actually just equal to log base 3 of 27 using the change of base formula. So the change of base formula just says that, if you have log base a of b, that's equal to log b over a of some new base. And I didn't go over the change of base formula in my previous video because you sort of never use it. This is like the only time I've ever used the change of base formula since like 10th grade. So I didn't go over it because it's really not that important. The important thing to know is that whether you solve your exponential equation with the base that's the same as the exponent here, and use base 3, or if you use just log base 10, you could use natural log, whatever you want, it will end up being the same thing. So you end up getting to the exact same step, so obviously you're going to get the same answer no matter which way you do it. So if you were to plug, if you did it this way and you were to get this here, you plug this into your calculator, it would come out to like 0.43 if you round it to 2 decimals. 1.43 over 0.477, which is equal to 2.99. So it's basically equal to 3. All right, so now let's go on to a slightly more complicated example, but still simple. So now we have 3 to the x plus 2 is equal to 27. So now if we wanted to solve this for x, we would take the log of both sides again. So I'm going to take the log base 3 of both sides. That's just the way I prefer to do it with the same base here, so that to me my algebra is simpler. But you can do it with whatever base you want. If you're more comfortable doing it with base 10, you can do it that way and we'll get the same final answer. So we take log of both sides. And so now here our exponent again goes in the front, so that entire x plus 2 goes in front here. We have log 3 base 3, so that's going to simplify to 1. And we're left with x plus 2 is equal to log base 3 of 27. We can subtract 2 from both sides, and we get our log minus 2. Plug this into your calculator, you get 3 for that. So then you're left with x is equal to 3 minus 2, so x is equal to 1. So it's important in questions like this, when you have like x plus something or some kind of function in your exponent here, make sure that that whole thing goes in front of your log. When you simplify from this step to this step, don't just put like the 2 in front or just the x. You have to put the whole x plus 2 in front. All right, now let's do a simple example with the natural log. So just like before, if we have the natural log of e, that's equal to 1 because we have the same base and our argument is the same. So that's because e to the 1 is equal to e. So natural log of e is equal to 1. So if we have an example, like let's say e to the x is equal to 5, and we want to figure out what x is. Now again, this is a very simple example, but we'll see some more complicated examples in a second. We take the natural log of both sides. Our x goes in front. This simplifies to just 1. And we're left with x is equal to ln 5, which we could have figured out if we just wrote this in exponential form right off the bat, but we'll do it the more long way first. Okay, and then you can just plug this into your calculator, and you get that x is equal to 1.6. And again, you could do this with any base in your log. If you wanted to do base 10 or base 2 or base 4, it would work. You would just have more steps, and it wouldn't really make sense when you could just do it much more easily using a natural log. All right, so now let's do some more complicated examples. So here we have 2 e to the 2x equals 5. So we want to try to isolate our exponent as much as possible before we start taking logs of both sides. So I'm going to divide both sides by 2. So I'm going to have e to the 2x is equal to 2.5. And now I can take the natural log of both sides. So again, if you wanted to do this with like log base 10, you could. It's just why would you? Because it would be more complicated. So whenever you have your e, you just want to use the natural log. So this will become 2x ln e is equal to ln of 2.5. This becomes just 1 here. So now we have 2x is equal to ln of 2.5. And now we can just divide by 2. And plug that into our calculator. So it's important here, you want to take the natural log of 2.5 and then divide by 2. You don't want to divide 2.5 by 2 and then take the natural log. So it's very important, make sure you keep your order of things correct. So we take the natural log of 2.5 and then divide by 2, and we get 0.46. So x is equal to 0.46. Okay, now let's do another example. So here we have e to the 3 minus 2x equals 4. So we can just jump right in and take the natural log of both sides here. So we're going to do ln of e to the 3 minus 2x is equal to ln 4. So our whole exponent gets put in front, so we have 3 minus 2x ln e is equal to ln 4. This simplifies to 1. And so now we just have 3 minus 2x is equal to ln 4. We can subtract 3 from both sides. So we have minus 2x is equal to ln 4 and then minus 3. So here parentheses might be important because we want to show that we're just taking the ln of 4 and then subtracting 3. And now we want to divide by negative 2. So we'll just divide by negative 2. So we get x is equal to ln of 4 minus 3 divided by negative 2. And you can plug this into your calculator and you get 0.8. All right, now let's do a more complicated example. So here we have e to the 2x minus e to the x is equal to 2. So this one you have to think about a little bit first and do a little bit of manipulation, because if we just try to jump right in and take the log of both sides, like the log of e to the 2x minus e to the x, that doesn't really help us. That doesn't simplify to anything. We can't really do anything with that. So that won't work. And we also can't simplify e to the 2x minus e to the x in any obvious way. It doesn't simplify, just e to the x or something like that. So we have to be a little bit clever. So what you can notice is that this looks kind of like a quadratic equation. So if I change this to e to the 2x minus e to the x minus 2 is equal to 0, that is of the form x squared minus x minus 2. Because e to the 2x is equal to e to the x squared. So if I sort of just replace e to the x with just x, I can see I have a quadratic equation here. So just like I can factor x squared minus x minus 2, that will factor to x minus 2 and x plus 1. So I'm going to factor this into this, but just replacing the x with e to the x. So I'm just going to factor this here, and I have e to the x minus 2, e to the x plus 1 is equal to 0. So now I can say, okay, now I have two factors. So either this one can be 0 or this one can be 0. So let's look at them separately. So for this one here, I have e to the x minus 2 is equal to 0, which is e to the x is equal to positive 2. And I can just take the natural log of both sides. in the same way we've been doing and end up with x is equal to ln 2. And so that's equal to about 0.7. Okay, so now I have my first solution here. So now let's look at this factor. So this one says e to the x plus 1 is equal to 0, which is e to the x is equal to -1. And now this one here, this has no solution. So I have no solution from this factor because there's no value of x that will make e to the x -1, right? We did that, we covered that in our previous video. So there's no solution here. So there's only one solution, which is x is equal to ln 2, and that is our answer. Okay, so the important thing to just keep in mind here is that when you see an exponential equation that looks like this, where you have like multiple exponents floating around, you can't just dive right in and take the log of both sides. You have to figure out a way to sort of condense it down so that you can look at just one at a time like we did here by factoring. Okay, so now let's look at another example that's similar. Okay, so this one you might look at and be like, okay, there's too many x's, too many exponentials, but there's actually a very simple trick here. So we're going to factor this one just like our last one. So we're going to notice that both terms here have an e to the x. So I can factor e to the x out. So I'm going to factor 2x squared plus x, and then I have e to the x factored out here. Now here, I can notice again that I have something times e to the x is equal to 0. Now we know that e to the x is never going to be equal to 0, right? Because there's no number that I can raise e to that will give me 0. So I can basically just divide out this e to the x because I know that's never going to be equal to 0. So just get rid of that part. And now I just have a regular factoring equation. So I just have 2x squared plus x is equal to 0. And you can just solve that any way you want. So, this we can just factor out an x again. We have 2x plus 1 is equal to 0. And then you can just solve for your x's here. And you get x is equal to 0 and -1/2. And that's it. So this, I think, was actually the easiest example, even though it looked very hard. Okay, so now let's go on to one more example. So for this one, I have an x on both sides of my equation in the exponent. So here I can just take the log of both sides right away. So I'm going to use base 2 just to make my algebra a little bit easier. But you could use base 10, you could use natural log, whatever you want. Okay, so I'm going to take the log base 2 of both sides. Okay, and now I can put my exponents in front. So the left-hand side is going to be 3x plus 1 log 2 base 2, and the right-hand side is going to be x minus 2, and then log of 3 base 2. Okay, so now this, I know, simplifies to 1. And so now I'm just left with 3x plus 1 is equal to x minus 2 log 3 base 2. So this now is basically just an algebra equation. Log of 3 base 2 is just some number. And then you just have to solve for x. So that's really it. So we're just going to do a little bit of algebra here, get all of our x's to one side. And get all of our constants to the other side. So I just moved this log of 3 gets distributed to both the x and the -2 here. So I just moved this x over this side, and then I moved the -1 over this side. So I get this. Now I can factor out an x here. So I get x 3 minus log base 3. And that's equal to this. And now I can just divide by both sides. So I get just divide by both sides, and then you get x is equal to this. So now this you can just plug into your calculator. So these are all just numbers. So just plug this all in, and be careful here. There's parentheses around this 3, so it's a log of 3 base 2, and then subtract 1. So just plug this in, and you get this is equal to -2.95. Okay, so that was it for our just a quick review of solving exponential equations. Our next one will be solving logarithmic equations. All right, I'll see you guys next time.